What's poppin', dogs? Mr. Allen here with a little application of circles when framing out a door. Interesting how we're going to use circles to frame out a door here. I get asked all the time, what's a math day in GeoCon look like? I always see you guys building. Well, here's a math day, all right? So we're framing a door with an arch at the top, okay? So not like a straight across, right? We're going to have a little arch, little decorative arch there. The door is 30 inches wide, and you want the arch to be 8 inches tall. What is the radius of the circle used to scribe this arch, okay, or an arc of the circle, right? So you could just try and like do your best there. I've seen people use like a string and a little guess and check, but you can actually math the situation up and calculate the radius here that you'd use, and then you'd be able to just take your tape measure and hook it to a nail and scribe that arch right there, that arc of the circle. But it takes a little bit of thought to figure out what this radius would be. So we're going to start drawing in some lines, okay? Let me get my ruler here. There it is. So first thing I want to do here is I'm going to scribe in a radius here, okay? So all the way to the edge right there, we're going to scribe this guy in. Boom. There's my radius. This is what I want, right? I want that variable right there. I want the radius of the circle because then I can just scribe this thing. Put a nail right here or a screw, hook your tape to it, and whoop, boom, good to go. So what else can we do here? Well, what if I were, because this height right here, that's going to be perpendicular right there, right? If you're framing this up correctly, it should be a right angle. What if I continue this this guy down, okay, and boom, all right. Now I have myself a right triangle. I didn't have to draw that right angle in there, but I figured now we can see a good right triangle here. Yes? Cool. But what are these lengths? Well, this is 30. The full width is 30, so this right here would be half of that, 15 inches. Okay, if this was 36, then you'd have 18 inches, right? 30 is a pretty standard interior door, whereas 36 would be more like your exterior entryway door. Fun fact, if you wanted to know. Anywho, so I've got 15 inches. I've got a radius that's unknown. Can I get this length right here? Well, if I had my radius, I could, right? But then I wouldn't be doing any of this stuff. But hold up. If I took my radius, whatever that radius is, and I subtract 8, that would be that length there, right? Because this guy plus 8 should equal the full radius. Now I have a right triangle, all in terms of one variable, my radius, that I can hit it with some Pythag and solve this thing. So we have everything that we need, okay? And we have our calculator in case the numbers get a little bit crazy, which I think they might. So we're going to do a little Pythag here. It's going to look a little scary because we got, a couple spots with the same variable, but hang tight, okay? So this is one of my side lengths, right? This will be, it'll be like r minus 8 quantity squared plus 15 squared equals r squared. Cool. I like that. That's good. Now I gotta FOIL this guy out, right? I can't distribute an exponent in. That's not allowed, right? I gotta make it where it's like r minus 8 times r minus 8 plus, what is that, 225 equals r squared. Cool. I'm good with that. Now we're going to FOIL this thing out. I think I might finish my math in here so it doesn't get all over my face and stuff, right? So r times r is r squared. R times negative 8 is negative 8r. Then I got negative 8r again. Boom. And then we have negative 8 times negative 8 is positive 64 plus 225 equals r squared. Okay. That fit perfectly in our little doorway. That's so wonderful. Now we can combine some like terms. I'm going to clean up the left-hand side first, okay? So we got r squared minus 16r, and then 64 and 225. What is that, 289? Okay? Equals r squared. Now, I want to solve for r, and thankfully, if I were to subtract r squared on both sides, those guys are gone, right? Boom, gone, gone. Boom, there we go, gone. So now I just have negative 16r plus 289 equals 0. Well, how about I add 16r to both sides? So then I'll have 289 equals 16r. And I can just take 289. Oops, I got to make sure that I'm clicked onto my calculator here. There we go. 289 divided by 16. Beautiful. 5 by 16. R equals 18.0625. All right, so 0.0625, that looks actually like a pretty familiar decimal, but I'm not totally sure. What I like to do to get into like reading a tape measure is I just isolate the decimal So you get 0.0625. I multiply that by 16 to get my 16ths on a tape measure. Hit enter. It is 1/16. So it was a pretty familiar one. I wasn't totally positive, but the 625 looked familiar. So we've got ourselves 18 and 1/16 inches for our radius. Boom. There we go. And now we can scribe this arc, take your little tape, pop a nail or a screw, and boom, 18 and 1/16. And actually, this will kind of work. You can derive a little formula as well. I'll link that in here. I made a little video on how to be able to take whatever you want for the height of the arch and half the width and just plug it in, and you'll get it every single time. So kind of a cool little thing. So, but that's the algebra that would be done to do that, but you don't have to do that every single time. If you notice a pattern, just pop it in there. But kind of cool because it involves, you know, properties of circles, which you don't think about very often in construction, but they do come up quite a bit, and they're super handy. And we always have right triangles within those circles because we're usually perpendicular to stuff, tangent to stuff. It's kind of neat. So hopefully you guys enjoyed it and watch some more videos, but that's it for this one. Have a great day.